This is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Please do not forget to like, share, subscribe, and click on the notification button to have more of my video. Now, today we are taking a topic on trigonometry ratio. So, trigonometry ratio is just talking about the relationship between the side and the angle in a right angle triangle. Look at this right angle triangle here. Let me say I have angle theta and angle beta, and I have this side as C, this side as A, and this side as B. The side that is facing angle 90 degree is called the hypotenuse. Hypotenuse. So trigonometry ratio is talking about relationship between this angle as well as the side of a right angle triangle. Now this ratio is summarized in this format. So this SOHCAHTOA is talking about sine theta opposite over hypotenuse, cos theta adjacent over hypotenuse, tan theta is opposite over adjacent. Now if I pick this angle theta here, the opposite of this theta is the side that is facing angle theta, and the side facing angle theta here is A. If I pick this beta, the side facing angle beta here is this side B. So the remaining side is always the hypotenuse. Now if I pick theta here, sine theta, according to SOHCAHTOA, opposite over hypotenuse, the opposite of this theta is A and the hypotenuse is C. Also, cos of that theta, that same theta, according to SOHCAHTOA, cos theta is adjacent over hypotenuse. This theta, the adjacent is the side that is not facing this theta, which is B over hypotenuse. That's a B all over C. And then tan theta, that theta, if you look at that theta, according to SOHCAHTOA, tan theta is opposite over adjacent. The opposite of this theta is A and the adjacent is a B. That is A all over B. Now, I want you to take note of something. If I make A subject to the formula here, I have C sine theta is equal to A. If I make B solve the formula here, I have C cos theta is equal to B. Now, this particular value that I have here, I can substitute for A here, and I can substitute for this B here. Therefore, tan theta can be expressed as a C sine theta for this A divided by C cos theta for this B. So this C cancels C. Therefore, tan theta can be expressed as sine theta divided by cos theta. What I have done for this angle theta, I can equally do it for angle beta. The opposite of beta is B, its adjacent is A, and the hypotenuse is C. You can go ahead and find the expression for the angle beta. Now, I also want us to take note of something. According to Pythagoras theorem, this side C, when you square it, is the sum of these other two sides. That's the side A square plus side B square. So now, if you look at this relationship that I have here, my C, this particular sine C square, I can rewrite it as this. I have A the other time, which is C sine theta square, plus, and the B that I have here is C cos theta. We square it. Now I have C square is equal to, if you open this bracket, we have C square sine square theta, plus if you open this bracket, that's C square cos square theta. I can factorize this C square out. So I have C square is equal to C square bracket sine square theta plus cos square theta. So if you divide both sides by C square, I have 1 is equal to sine square theta plus cos square theta. Please take note of this standard trigonometry ratio that I've already derived here. So now we want to go into what is called special angles. when we talk about special angles, we need to remember this. We consider a square of side 1 units, and we also consider a right angle triangle. We also consider equilateral triangle of side 2, 2, 2, and the interior angle for this equilateral is 60 degree, 60 degree, and 60 degree. Then another thing we need to consider when we are referring to special angle is a full cycle. If you divide this full cycle into 4 equal parts, if I start from here, I write angle 0 degree. If I had 90 to 0 degree, 0 plus 90 will give me 90. So here will be 90 degree. So if I had 90 to this 90 again, I have a 180 degree at this point. If I had 90 degree to 180, I'm going to have 270 degree. If I had 270 degree, if I had 90 degree to 270 degree, I'm going to have 360 degree. So the special angle we are referring to, I want to write them out here. I talk about this particular square. If you divide this square into 2 equal parts, the angle you are going to have here will be 45 degree, 45 degree. So the first special angle we are going to talk about is angle 45 degree. If I divide this equilateral triangle into 2 equal parts, the angle that will be here and here will be 30, 30. So if you consider this side of equilateral triangle, we are going to have the angle 30 and angle 60. So another special angle is angle 30 degree and then angle 60 degree. Now if you look at this circle that I have, all the angles that I've indicated here, they are special angle. So we have angle 0 degree, then followed by angle 90 degree, then followed by angle 180 degree, followed by angle 270 degree, then followed by angle 360 degree. So all these are called special angles. So I want to develop trigonometry ratio for this our special angle. Let me consider angle 45 degree. Like I said the other time, when you are considering angle 45 degree, think of a square, a unit square of side 1 unit, and the interior angle angle 90 degree each. If you divide this square into 2 here like this, the angle here will be 45 degree and the angle here will be 45 degree. So if I bring this triangle out, this side of the triangle out here, what I'm going to have will be angle 45 degree, angle 45 degree, and this one is this and this one is this. So this particular hypotenuse, I can use the Pythagoras theorem. According to Pythagoras theorem, if you look at a right angle triangle of this nature, let's say we have side C, A, and B. Pythagoras theorem says the hypotenuse, the longest side of the right angle triangle, when we square it, is the addition of the other 2 sides of the triangle, which is A square plus B square. So if you use this particular Pythagoras theorem, we can get this value for H. So that means A square is equal to 1 square plus 1 square. So that is 1 plus 1 will give us 2. So H will be square root of 2. So I can rewrite this right angle triangle out like this: 45 degree, 45 degree. This is root 2, and this is 1, 1. So we can use this particular triangle to generate the trigonometry ratio for angle 45 degree. Now we talk about sine 45 degree. According to Sokatua, sine theta is opposite over hypotenuse, opposite over hypotenuse. The opposite of, if I pick this angle 45, the opposite of it is 1, and the hypotenuse is root 2. So opposite is 1 divided by root 2. If I rationalize this, I use root 2 to multiply up and down, I'm going to have root 2 all over 2. That's sine 45. Then cos 45 degree, according to Sokatua, is adjacent over hypotenuse. Adjacent is 1, hypotenuse is root 2. So if I rationalize using this root 2 to multiply up and down, I'm going to have root 2 divided by 2. Now, like I said the other time, you know that tan theta is equal to sine theta divided by cos theta. Therefore, tan 45 degree can also be written as sine 45 degree divided by cos 45 degree without using this triangle. So sine 45 degree that we obtain here is 1 all over root 2 divided by 1 all over root 2. These two cancel each other out and you have it as 1. So now, please, before I go further to the second trigonometry ratio of 30 and 60, take note of this. I've established the fact that cos square theta plus sine square theta is equal to 1. That's what I established here in the proving here. So I want to generate some trigonometry ratio here. If you divide through by cos square theta, I'm going to have cos square theta all over cos square theta all over cos square theta. So cos square theta divided by cos square theta will give you 1 plus sine square theta all over cos square theta is equal to 1 over cos square theta. Now, before I go further, we have what is called inverse trigonometry ratio. Inverse. The inverse of sine theta, the inverse of it is 1 all over sine theta, and is given as cosec theta. So the third letter of cosec theta is s. So s go with sine. So therefore, the inverse of sine theta is cosec theta. Then the inverse of cos theta is 1 over cos theta, and is given as sec theta. The third letter here is c. The c go with c. So then for the tan theta, the inverse of tan theta is 1 over tan theta, and this 1 over tan theta is known as cotan theta. The third letter of cotan theta is t, so t go with tan theta. So look at it very well. Inverse of sine theta is cosec theta, inverse of cos theta is sec theta, inverse of tan theta is cotan theta. So if you look at it here, I have established that sine theta divided by cos theta, which I have somewhere here. I established sine theta over cos theta. So sine square theta divided by cos square theta is going to give us tan square theta. And then 1 over cos square theta from this inverse trigonometry ratio is sec theta. So it's going to be sec square theta. So another case is when we divide through by sine square theta. This particular expression, when we divide through by sine square theta, I'm going to have cos square theta all over sine square theta plus sine square theta all over sine square theta is equal to 1 all over sine square theta. Now, if you look at what we have here, this is cos theta over sine theta. That is the inverse of tan theta. So this one actually means 1 all over tan square theta. Then sine square theta divided by sine square theta will give us 1. 1 over sine square theta from this inverse trigonometry ratio is cosec square theta. Cosec square theta. Now 1 over tan square theta from the inverse trigonometry ratio is cota square theta. So I will put cotan square theta plus 1 is equal to cosec square theta. So these are trigonometry ratio that you need to take note of. All these trigonometry ratio, you take note of them. Now, for the trigonometry ratio of angle 30 and 60 degree, I'm going to demonstrate that in my next video. The next video will be on trigonometry ratio for angle, the special angle 30, 60. Then I will also do the other special angle there. I'm looking forward to you. Please do not forget to like, share, and subscribe. Thank you. Bye.